I'll be talking today about the unreasonable effectiveness of product sense in data science. And for those of you who kind of don't get a reference, it's based on another kind of paper that was published about the unreasonable effectiveness of machine learning. But here we kind of play on that, and what I'll try to kind of walk you through is how important product sense is in kind of what we do. So since Daniel already have done a tremendous job introducing me, you can kind of skip. I just kind of added a joke that if you folks remember the times that we used to go to school that weren't all University of Phoenix. So that wasn't the time I went to school. So today, just to make it kind of a little bit lighter, we're gonna kind of do this myth buster episode. By the way, rest in peace, Grant Imahara, who unfortunately, passed away about a week or so ago. But we're gonna do kind of a myth-busting episode about certain myths that people believe around across data products. The first myth we're going to start with is that data products are about displaying data. And that myth is kind of, came to be famous about one of the kind of most popular analytics products in the world, which is Google Analytics. And let me just kind of move the screen a little bit. So Google Analytics is this kind of canvas where Google vomits a lot of data points into, and they expect you kind of to figure things out. Like you start a business, and then your business will suddenly become extremely successful because you have data, right? Well, not necessarily, because let's see how this kind of concept applies to on some other problems that we're trying to solve. Sorry. Problems like, for example, navigation. So for anyone who ever kind of drove a car and had to get to a certain point, probably the interface that you have seen did not look like this, where you got kind of a distribution of at every intersection, how many people have turned right, how many people turn left, and how many people kind of continue straight. But some of you might say, well, Vitaly, you're kind of cheating here because you're actually like not displaying the data like a true data professional. If you like displayed it better, then maybe that would be, kind of an applicable way to advise people what to do. So here we go, a pie chart. So now you have a pie chart that, kind of conveys the same exact information, but probably it's not much better at actually displaying really the action that a person needs to take in order to get wherever they're going. Or we're saying, well, maybe that's just kind of not enough data. So maybe we need just a giant dashboard of all of the possible, and like we actually have not accounted for weather, we haven't accounted for traffic pattern, and we don't get historical data. So like, how do we know where to go? Like now we have this dashboard, and we can apply it. Now you probably need a Tesla, like one of the ones that Daniel drives, in order to fit all that screen. But now that you have like a big Tesla with a giant screen, you can actually get this dashboard there, and you can actually kind of look at that information. But obviously, kind of hopefully the world came to a better conclusion, and they came on this system that we kind of affectionately call GPS. And really what GPS provides us is kind of really an actionable system that guides you and tells you where to go at every point you need to make a decision. Additional thing that GPS adds is, if you can see, they also kind of guide you around like why they made the decision. So they kind of might propose alternative routes. They might show you how much time you're saving by going down the suggested route. They show you kind of, like I said, alternative. They show which parts of the route are optimal and kind of suboptimal, and so you can also decide accordingly. So there's one thing that you can take from the entire talk and this entire kind of episode of Mythbuster is try to kind of design systems that look more like a GPS rather than Google Analytics. Really, kind of that's the gist of it. So myth number one, data products are about displaying data, hopefully busted. The myth number two is user will behave as expected. And this, I take an example from past employer of both Daniels and myself, is LinkedIn. And this is a former colleague of mine who's a data scientist, who was a data scientist at LinkedIn, currently at Salesforce. And as you can see, LinkedIn has this awesome feature that says people who viewed that profile also viewed. And for those of you who ever use it, it actually seems to be a quite useful feature. And the thinking behind it is, well, when people look for data scientists, they look for other data scientists, they might click on something, and these people are probably connected. And really, that's a useful way to display information, and that's a great product because people tend to click on similar profiles, and by similar means, similar in kind of relevance. But that's not always the case. Where if we take this lady and we look at her similar profiles, we find slightly different sort of relevance. And if you look at, and this is like a real profile that is kind of unfortunately on LinkedIn, you might see that the recommendations there are somewhat, let's call it, not very relevant in the kind of relevant set that probably the people who work at this product imagined. As you can see, there is a territory account manager, there's a photography intern at the Green Bay Packers, there are field producers, and people who actually have nothing to do with kind of professional relevance. But I'm sure all of you can guess what is the relevance that made these profiles appear there. And basically the point is, like, people just click on images that they like, and a lot of it and a lot of these clicks kind of are not really a signal of relevance. It's more of a signal that people are bored at home and trying kind of to spend time by browsing profiles. And so really this is kind of an unfortunate case where these things kind of need to be tested, and really not every action is representative of what we want, which drives us kind of myth number 2, which is busted as well. Users will not just behave as expected. And really kind of this is a continuation of this myth where people say optimize for click, and really what drives kind of this myth is the famous Google page, where one of the things that Google search and really made Google incredible and really kind of the most powerful search in the world, and obviously now a $1 trillion company, is the way that their relevance algorithm works, and which is not this whole page rank, but also they actually take into account using a technique called learn to rank what people are searching and what people ended up clicking. And this kind of gave birth to, like we said, the most kind of powerful, popular search engine in the world, and obviously one of the largest companies to ever exist. But as you might know, and not just from the previous example, there are certain limitations to this optimizing for clicks, which as we are all aware in social media, tends to lead for articles that since then have been coined as clickbait articles, right? You'll never believe, and then click to find out what is going on. Another example, this baby girl reaction, blah, 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 and really kind of things that unfortunately now we have an entire media industry that tries to kind of use these articles in order to kind of convince people to buy, so they can claim that users have seen their ad displays and that they can basically charge the advertisers on their platform. But really kind of this is something that is also important. Like there is a certain thing that we want to optimize, and action seems very, very good thing to optimize for, but unfortunately we have to really dig deeper and understand what is the actual action. And the actual action is probably more like people actually staying and reading the article. So how do we optimize for this? How do we measure it? And really kind of the lesson we learn is taking the extra step and not choosing a kind of a simple proxy that ends up optimizing for the wrong thing. And another way to do it is also, so these are two examples of kind of social media, what we call kind of explicit feedback. But unfortunately, in many systems, we don't have we don't have a negative feedback. So in the negative feedback in a lot of systems is actually kind of an implicit feedback. Like if I don't click on something, or I don't like something, or I don't share something, it means that this is probably not a great article. But in some cases, if you think about systems like Netflix, where you actually rate a movie and you give something a star in between 1 and 5, that tends to lead to much better recommendation system, because you actually collect explicit feedback, which is not just kind of testament by omission, but really kind of the feedback that you get is telling you that, hey, that recommendation or that sort of machine learning thing was not the best one. And so the advice here is, if you can, try to add a mechanism to also add an explicitly negative feedback to your products, so you can actually measure kind of and deliver better recommendation, as opposed to just applying an implicit bias. So kind of I want to share a quote, and I actually couldn't find who said it, but left unchecked, all optimization leads to gambling and porn. That's really kind of one way to think about it. So myth number 3, optimize for clicks, busted as well. So here is another one, which is people like, and I think with especially with the CERN advance in kind of deep learning and a lot of the research that has been conducted in the space, we're starting to kind of develop more and more complex algorithms and model. Like, for example, all the rage now recently on Twitter in the last week or two is GPT-3, which is kind of the largest model ever produced, that is now kind of basically will replace all of us in a matter of months, and we'll stop having a job. But until then, I would like to argue that in some cases, maybe we can think about this problem a little bit differently. And I'd like to start with a use case, which is a system that we used to have, we still have at Salesforce. I'm no longer just with Salesforce, which we call Social Studio, which is a product where brands manage their social activities across different channels, across Facebook, Twitter, blog posts, kind of whatever. So that is kind of how this thing looks like. And really one of the main reasons is because you have so much interaction across multiple channels, and you usually have kind of customer success or social kind of media managers respond to certain kind of inquiries, complaints, or kind of other things that people post on these social media. And here's an example from this gentleman called Eddie Russell that complained on KLM. That was back when people were allowed to fly. That kids just got back from Amsterdam. KLM totally ruined the trip, paid 3 times this for the same suitcase. KLM were rude and unhelpful, and so on and so forth. So the problem with these systems, which is one of the problems that we had to address back in Salesforce, is that we don't really know who Eddie Russell is. And it might be a very common name, and the Eddie SOI is also not very indicative. Really, in order for KLM to try to tackle this problem, they have to perform some sort of mapping between the identity of that person on Twitter and the identity of that person in the KLM system. And these problems, as someone who's kind of working on a similar one today, part of my current startup, is these problems are not easy. And really kind of how a machine learning pipeline might look like, this is not really the machine learning that solved this. This is just a kind of a screenshot I took from the Uber Michelangelo post, but this is kind of an accurate depiction of like what machine learning platforms kind of advanced look like. The Einstein Salesforce Einstein one look very similar. And as you can see, you have an offline pipeline, you have an online pipeline, you have data lakes, you have Kafka streams, you have feature stores, you have training jobs, you have prediction jobs, you have real-time prediction service. And really, in order to build a reliable system, which is this doesn't even include all of the NLP models that you will need in order to solve the problem of kind of mapping between identities across two different systems. So KLM could have kind of built that system, but instead they decided to take kind of some other approach to the situation. And really, they replied, "Hi, thank you for sharing your story with us. Can you share the booking code via direct message?" And really, while this might kind of really not be as appealing to us, people who like to build kind of machine learning systems, that's not as fancy of an approach. It's not automated at all. It requires an extra command. But as you can imagine, this saved a lot of time to KLM by actually just asking people for their identity in their own system as opposed to actually trying to build it. And this is kind of, again, it's obviously a trivial example, but it illustrates a bigger point that you should start with kind of, if you think about the MVP, like not everything has to be solved using a machine learning model. Not everything has to be solved using a complex machine learning model. A former colleague of Daniel's and mine at LinkedIn, Monica Rugati, used to say that her favorite machine learning algorithm is division. And because really a lot of the things that you need to do, you can just get to by taking one number and dividing it by another. So complex algorithms beat simple algorithms. This one is busted as well. And this is kind of our last one, which is, users want to configure things for themselves. And this comes from also this notion where people really want to kind of see their recommendations, see like things and see personalized, and they have kind of these preferences around like exactly that everything is super tailored, super personalized, and kind of super everything. And they actually like personalization means different things to different people. So a lot of time, product people kind of go the extra mile in trying to adjust many systems to individuals, and really, in some cases, is just unnecessary. And one of my kind of favorite examples here is if you look at Google, which really kind of the UI there did not change for the last 20 years, right? I'm saying it's just a search box, and without asking you anything about you, somehow what they know is like if you if you are an engineer in Silicon Valley and you type Python, you probably will get something similar to this, where it's a lot of references to the kind of programming language. While if you probably have nothing to do, you'll get something, well, I had to actually type the word snake in order to kind of explain Google that that's what I'm looking. But this is kind of enough. I didn't have to go to Google, some configuration screen, and kind of teach it that I'm an engineer. When I say this, I actually want to get a reference for engineering. It kind of learned about me and just give me just a much better kind of this initial experience. And B, it actually, there is this escape hatch where if I really want to get to what we're kind of looking is, I just add another word and I said Python snake, and then it's pretty clear what I'm kind of looking for at this point. There is also a cautionary tale there that it doesn't always work, because when I started at LinkedIn, we still had a search engine there where you had basically kind of 4 separate search engines for people, jobs, companies, and groups. And at some point, we kind of also wanted to kind of create this more unified experience where people just search, and we will identify from that examples what is actually the search term that they're looking. And so in some cases, if they're looking for a company, like let's say in kind of Google, then we know that this is the name of company, so we'll show them information about the company. But if they want, for example, to work at Google and want to see some job openings, they can type kind of Google jobs. The unfortunate part there, while I think he passed away already by that point, but still there were many searches for Steve Jobs, which unfortunately led to job openings at companies called Steve, which again, this is also something just to be a little bit aware of, and that's kind of where was fixed later. But that is kind of just another example, but really kind of one of my favorite quotes in designing products at all, and especially products that have kind of machine learning or the more modern, cooler term AI in them, is that really any sufficiently advanced technology is indistinguishable from magic. That's one of Clarke's kind of free laws. And in that case, that really the user would want to configure, this is actually in most cases just also not true, and really you should avoid of kind of doing it. So really, I think these were all the myths that I had for today. And this is kind of a chef displaying one moment where he was actually nice to people, because I think it was the kids' show. So I guess he had to be nice. But thank you for kind of listening to my rambling.